There we go. Hello, welcome to the stream. I think we got some new faces here. This is great. Thanks for coming. If you didn't know, this is your first time to the stream, excuse me, we are working on a little game using the Bevy game engine, which is written in Rust. Bevy, as I've said before on previous streams, has a really sophisticated entity component system toolkit. So you are not building object hierarchies, you are building a game database, essentially, with different tables. And you can have queries over those things, and it's really pretty cool. I think it's a bit of a mind-bending way to write a game, but it lends itself to really modular focused code, and I'm pretty excited to be working on it. We've done 2 or 3 sessions so far, and it's gone really well. We have something that's running. It's not really a game in the sense that there aren't mechanics, at least not mechanics that let you win or lose. There are mechanics that move the characters around the screen, and that's about it. And so we're building a little Survivors roguelike game. So if you ever played Vampire Survivors, or if you've played Hades, or if you've played any of these other Survivor clones, you will be familiar with the genre. And I mostly am doing this because it's an easy game style to understand and to emulate. Top-down view. We're not doing any 3D. It's all 2D. We got sprites moving around. Basically, hello, Isaac. Happy holidays. Thanks for coming back. Yeah, and you've got, like I mentioned, 2D. It's sprites, so it's going to be easier to get started and have something working. And yeah, I'm just really excited about it. And we'll get started here. Folks are trickling in. And if this is your first time in the chat, please drop a hello. And I would love to hear about what brought you here. Anyway, so let's switch to the coding screen. Okay, so last time we finished some things which were pretty significant that I'm really happy about. And we came up with some things that we could do in the future. And as usual, I'm using Emacs to keep track of my to-do list here. So one of the things we did late in the last stream was we thought we were spawning enemies on a unit square, and then scaling that square to the screen so that they would appear to spawn at the edge or beyond the edge of the screen and move toward the player. Well, that's not actually the case because the math was wrong. So we may want to fix that. Maybe that'll be a good small task. So we were spawning on a unit circle, not on a square. So when we scaled it, it was actually an ellipse and not a rectangle. So what I was thinking was we would fix the math on that, and it's actually really simple. So we generate a random angle, so like a unit vector that's on an angle, which will be on the unit circle, right? And then if we want it to be on the unit square, well, how would that work? Let me see if I have anything to draw with. Well, let's do an easel. Can I make a new easel? How do you work? Easels. Here we are. New easel. There we go. Okay. So what we were spawning was on a unit circle, and what we want is to spawn. We want to scale that to the unit square and send it back. Okay. So if our vector looks like this, let's do something like that. And what we want is to be that, right? This first vector that we drew is always going to be length 1. But you notice that it's not, my dimensions are all wrong here. Let's fix the square real quick. No, yes, this easel is too helpful. There we go. Okay, so let's bring it in. Let's bring it in so it's touching. Get this vector back lined up. Okay, so what we want is something in the same direction, but to be touching the outer part of this unit square, right? So what we can do is find out what the largest dimension is. In this case, it'll be x, right? So if you're thinking Pythagorean theorem, you'll have a vector that looks like this, and let's do it in purple, and then you'll have one that looks like this, and that's not exactly right, but close enough. Okay, so we'll have an x vector, or an x projection and a y projection. We just need to know which dimension is the biggest, and then we'll divide by that because this is on a unit square or unit circle, and we want that dimension to be 1, right? So if this was pointing more up, we would know that the y direction was bigger. This is absolute value bigger, right? And so we want that to point mostly up and be along that upper edge of the square. So we're going to divide by the largest dimension, the absolute value of the largest dimension, and then we'll get this blue, this navy blue or royal blue vector rather than the light blue one. Clear? Okay. Let's go back. Okay, so we're in this repository. I haven't done anything since last week when we made our first commit. So let's have a look at where we are. Okay, wrong one. Okay, so our enemies are just ghosts right now. We'll probably generalize this later to be a to be just enemies, and maybe we'll pull, rather than it being a ghost with particular sprite, maybe we'll have some separate data files that'll fill this out for us. But for now, what we are going to do is fix this stuff. So why don't we just comment this out, and we need to keep this here so that we can make use of it. But let's say let angle. We're going to generate something in the range from 0 F32 to F32 pi constant. It's standard. Sorry, I need to remember those constants are. Cons pi. Do they have a 2 pi? Pi 2, fractional pi 2. They have tau. Tau. We use tau. Okay, so we're going to generate something between 0 and tau, which is 2 pi, right? So that's the angle in radians of this vector. Okay, and then we will say we'll just keep this very clear, similar to the math that we were looking at earlier. Let me pull this up so we can see it on the side. And so we have the unit vector is going to be vec2 from angle, angle, and then we're going to extend it. Now let's do the math in 2D first, and then we'll extend it to include the 0, because previously in the previous stream we had mentioned that all the dimensions in Bevy are 3D, even if you're doing a 2D game. So usually it means adding 0 for the Z dimension. Okay, and then we're going to say let's say unit vector dot x dot abs, right? Because this is, if that's less than the unit vector dot y dot abs, then what we want is, let's say square, vector on square. We'll be really verbose here on the variable names. Okay, so if the x value is less than the y value, then the y is the greater one, right? So what we want to do is unit vector divided by unit vector dot y dot abs. So what will this do? So if the y dimension is bigger, then what we don't want is to divide by the current value of y, because that'll change the direction. We only want to divide by a magnitude, right? We don't care about the direction, you know, when we're trying to scale this up to the unit square. Okay, and then otherwise we'll use the x. So if y was negative, but if the absolute value of it was greater, so if that was the longer dimension, and then we divided by a negative, we would flip the vector going in the opposite direction. We don't want to do that because that'll put bias in our spawning directions. So always dividing by the absolute value there. So what does this mean? This will mean that that dimension will get scaled to 1, and then and the other dimension will get scaled proportionally. I'm actually concerned that maybe what we'll do is we'll debug this here. Because I'm actually concerned that this will, if it'll scale the smaller dimension more. Maybe I'm just trying too hard. We could have left what we had. Okay. Well, let's just vector on square, spawning at angle, vector on square. And if you're new to Rust, by the way, these are format strings. This info macro comes from Bevy. It lets you use their built-in logging. Okay, and then our spawn spot is going to be similar. So let's go ahead and put that back in here. That's going to be vector on square. And then we used this scaling factor. Except we need to extend that and put 0 in the z dimension. We need our direction in there as well. Okay, so we have a new spawn spot, which is fine for the transform translation. And then our direction is always going toward the center. Do you need a special distribution? What do you mean by a special distribution? Just using a uniform random. If you're talking about the random distribution. The other thing that I could potentially do is a little bit more trigonometry, and say, you know, do some like figuring out, it's probably the opposite. Okay, it might be the sine. So if whatever, we'll think about that. Let's see how this works. I think what we're going to get here, based on my understanding of the math, is that because we're dividing by the longer dimension to make that equal to 1, we're actually going to make the smaller dimension larger, because these are all 1 or smaller, right? Yeah, the random distribution around the square. Yeah. The other thing that we could do potentially is go think about the distance along the square, and think about, ranges of the 4 quadrants of the square. So around the perimeter, we could generate a number between 0 and 4, and then go, well, if it's between 0 and half, it's on this one. 0 and 1, it's here. 0 and 1.5, and so forth. Yeah, then you could do a 4 dice roll for the direction, the -1 +1 roll. That's true. We could do that. So I don't know. This is just a little math thing that I wanted to ponder and try. So let's see what we got here when we run this. Oops, typoed that. And we're gonna pop that up so we can see the scroll. You can see. So interestingly, none of the smaller dimensions are coming out bigger than 1. So I think we're probably okay. Those are all within 0 to 1. Okay. And that's actually, I should restart it. Let's look at it visually. Okay, so remember we got our guy here, and there come the enemies from off the screen. Okay. Cool. Okay, let's remove this info line. I think this is fine. And let's make a quick commit. Oh my goodness, yeah, all those assets are not included. I might have to make a git ignore for that and add one specifically back. So spawn enemies on a square, on a rectangle, let's say, rather than an ellipse. And this, this particular mechanic might not be that useful longer term, but I wanted to be a little bit consistent with how I perceive that these games work. So, and yeah, Isaac, that was a great suggestion. If we get to the point where this is no longer sufficient, then we'll do that, like 4 dice roll and then a -1 +1, which should be sufficient. 4-sided die can't exist in real life. Okay, let's look at our to-do list. So we got them spawning in the correct place, and we generated an angle, etc., projected onto the unit square. Okay, we'll probably add some more things for the player later. And we did screen size last time. Let's talk about collisions. I think that would be, this is going to be a foundation of some things we'll do later. And there are a bunch of crates out there for Bevy games that handle this sort of stuff for you. And I didn't want to, partly because I want to learn it along with you all, but also some of them are really complicated. And I think if we were trying to build a really sophisticated a sophisticated game that needed some complicated physics, I would reach for those. Number one, I would say, like, for this type of game, Rapier 2D would be the thing. However, as I understand it, Rapier 2D is more focused on side view type of physics, and we want top-down view physics. So I'm not sure about whether it would even be appropriate. However, what we would potentially be able to do with it is focus more on our inputs to the physics system and less on the mechanics of how the physics system works. Anyway, let's do a really simple collision detection system. So we're going to have to make a new module, and I'll call it collision. And let's make that file. Okay. So use Bevy prelude again. This is going to be the tired thing that you do in every file. Okay, so we're going to make a collision plugin like we do with every other file in here. If you're new to the stream, Bevy has a sort of structure that it wants you to build. So you may have noticed over here in Ghost, this is a system in its entity component system framework. It's like just a function, and it takes specific arguments that it detects at compile time. But how you hook it up is these plugins. So your plugin is passed what's called the app, and this is basically all the state for the game, including the world and the renderer and all that goop. And then for each sort of module that you're making, you make a plugin. So you implement this trait for a struct. It's usually an empty struct, like a zero size struct. And then you do some things. So this is when it's past the app, this will insert a spawn timer, and it will add systems, spawn ghost, and chase player to the update phase of the game loop. Okay, so then in the main file, which is where your app starts from, you just add plugins as you go. So this way you can keep it modular. The order of their insertion is not important. It's what they do with the app when they get it. So, okay, so we're going to do the same for collision plugin. Okay, and we can leave that to do. So what we want to do, let's make a component. We'll do it down below the plugin. Collider. And I'm not sure what's going to be in this yet. I actually have a pretty good idea, but we want this to be a component that we can add to the entities in our systems. Entities in our game world is probably a better way to put it. And this will be a combination of both a marker, so like this thing in the world can collide with other things, but it'll also hold the state for what this thing has collided with and how to determine whether it has collided with something. So we have to store some sense of what are the boundaries of this thing. So what I would like to do is say, let's just make a size field, and let's make it a vec2. And the reason I'm doing this, we may want to do this as half extents, because it'll be based on the center. But this is sort of like an axis-aligned bounding box, except it's not positioned. It would be positioned over the center of the entity, right? And this one may be a little bit less clear, but we're gonna keep a list of the collisions. So things that it is currently colliding with. This is as I may have mentioned before, this is going to be very rudimentary. And it is also going to be potentially not scalable, because we're going to do a cross product basically of all of the entities that have colliders. So let's start writing that system. Let's say detect collisions. Pub fun. Actually, it doesn't need to be pub. Okay, we don't know what we need in that yet, but let's go ahead and add it. Add systems, and we're going to say on update, and we'll have to be concerned with where this happens in the future. But yep. I was thinking one thing we may also want to do is add a translation for this size, because I think I don't have Steam open, so I can't launch Crafty Survivors. But one thing I've noticed about playing that game is that the collision box is not actually the whole character. It's like 75% of the character or so, maybe 50%, based on the bottom, like the visible bottom of that character. So this means that you could, if there's something that's farther down the screen, you could go past it, passing through the top portion of the character, and then you get a little bit of a perspective type thing, and it doesn't look like you've collided with it. So we may want to do something like that for fairness, but we can deal with that later. For now, let's just say we're going to detect rectangles overlapping, because rectangles, the two probably simplest collision detection. This is about geometry, right? So let's go back to our easel real quick. So we could do circles, in which case, are these two things colliding? Oops. If these two things are colliding, then which means they're touching or overlapping, right? How you detect that is, what's the distance between their centers, the centers of their circles, and then what's this distance, and is that greater than the sum of the radii of the circles? So circles are really easy to do, and rectangles are similarly easy, except that let's make that one orange here. So all you have to do is determine, is any corner, I say all you have to do, what you have to do is any corner of one rectangle within the bounds of the other. So there's a bit of checking the corners, which I think will be okay. There might even be something in Glam that can help us with that. I don't remember. Let's see if I have Glam in here. I do. So Glam is the math library that Bevy uses. It's just Vex. So let's see Vec2s. Yeah, so we might want to figure out what the math is going to be on our rectangles. But for the meantime, let's get this going. Okay, so we're going to have a query, as we do in all of our systems, or pretty much all of them. And what we want to do is get all the entities, and that needs to, no, that's copy. Okay, and then we'll see which ones are colliders. So if they have a collider on them, and we probably want the transform as well, right? Because we need to detect the transform. Detect, are they overlapping, right? Okay, and then we're going to do a simple cross product. So we're going to say entity A, transform A, and this is going to have to be mute query. We don't need it in the first one. We're just trying to detect. Let's make a hash map here. And this is going to be, let's just call it collisions. Hash map new. And just for clarity, we're gonna, this is gonna be a hash map of entity to vec of entity. Okay. So we're gonna do this. We're just gonna do a detection phase, and then we'll do another phase, which is record the collisions. Okay. In query.iter. Okay, and then we'll have entity B, transform B, collider, and this needs to be collider A. B. So, you know, not the most efficient, but we're already leaning on the entity component system framework to give us only the things that have colliders in them. Okay. Yeah, and we'll do some stuff down below probably to fix this up. Okay. So here's where our detection is going to happen, and I'm a little bit intimidated, so bear with me. Okay, so we want to, we're going to skip, those. So if they're the same entity, can't collide with yourself. Let's put a little note in here. Don't collide with yourself. And then let's look at okay, let's see what the min point of A is. Let's start with that, because we think about it with respect to our diagram here. Let's say the orange one is A. Excuse me, my cat is playing with some plastic wrap over there. My apologies. You can probably hear that. So what we want to do is find this top left corner, and we want to find the bottom right corner. So we're going to take transform A, translation, and there's a method on vec3 to get, is it truncate? Yeah, so it gives us a vec2. Okay, and then we're going to say we're going to minus, we're going to subtract half of the size. Okay, so this is, on this example, what we're doing is we're going from the center of the transform to the top left edge with this. And let's say max A, and we'll do the same for B, right? Now, what we can do actually is, since we're iterating over these, let's put this out here. These don't have to be mutable, right? And then we want to do the other direction, half extent. So we're going to not subtract, but we're going to add size divided by 2. Okay. All right. And then we'll do the same for B. B, mid B. And size, we need to be more clear about that. That size is not in scope. This is collider A dot size. Right? And this is collider B dot size. Okay. So let's think about some different conditions here. So it is entirely possible that one of the dimensions overlaps and not the other, right? So in this case, they are not colliding, right? But if two dimensions are overlapping, then it would be colliding. So let's break that out into two different calculations, right? Overlap X. Okay, so we're going to say interestingly, it probably doesn't matter which one of these we check, because we could check, does this one fit into that one, or does this one fit into that one? But they're actually the same condition, right? So we only need to check, does any of A's points fit within the bounds of B? So if it's overlapping in the X, then either the max X or the min X are between the min X and max X of the other one, right? Yeah. I have not done Abedico this year. I actually did it quite a bit last year. But yeah, it always has these sorts of challenges, right? But I just want to think through this because I think it's useful. Like obviously the circle one we could have had done in like just a minute, but this is a little bit more complicated because we're trying to deal with ranges, right? So now we could do yeah, let's think about it that way. So let's say if min b dot x to max b dot x, right? Includes, contains. Okay. Let's see if it contains min a dot x, or so that would be this case. So min a is inside the x dimension there. And the other option is what we had before, which is like this. So we want to see if it contains max a dot x. Oh, and I have some math wrong here. My cat, wow. My cat went to the vet yesterday and got her teeth cleaned. So she had to be sedated, and now today she's all crazy. Okay, so contains on an iterator takes a reference. That's a little weird for these, but it's fine. Okay, so that's overlap X, right? And we can duplicate that for Y. And let's just change all these to Y. Make sure I don't do any errors there. Call me out if I do. This is a very typo-prone situation. Okay, so if overlap X and overlap Y, so they both have to be overlapping. Remember, if it's like this, or say like this, you know, you have one dimension overlapping, but the other one doesn't. So it has to be at least It has to be both dimensions overlapping in any configuration. Okay, so what we're going to do here is we're going to make use of the entry API on collisions. So we're going to say collisions, and let's do this with, let's track these for the A's, and when we get to the B, when we come around, like, we're skipping the ones that are the same. We'll have duplicate data here, but it's fine. Okay, so collisions.entry, and we're going to see entity A. Or default. So what this is doing is this is getting a mutable reference to the key, to the value associated with the key with this entity in this hash map. That's what this entry API does. And this entry is like, it's a wrapper struct, right? And it has a bunch of nice methods on it. So this means that we can kind of upsert our collection of entities. If we haven't recorded one for this one yet, we'll insert an empty vector, excuse me, into the hash map. And then what this returns, this or default returns a mutable reference to the value. So we've got the vec of entities here, and then we'll push entity B. Okay. Let's see here. What's wrong? Oh, okay. I forgot. Keys are not required to be cloned, so you have to actually pass it. But the entity type in the Bevy framework is copy. So in this case, we don't have to clone it explicitly. So now we've gone through all the entities that have colliders, and we've checked if they overlap with any other thing. What if one rect is bigger than the other, or do all entities have the same size? That's a good question, and it actually doesn't matter in this case, because we are finding the min and max point of each entity individually based on its size, and we haven't determined the size yet because we haven't added any colliders to any entities yet. But essentially, we get the midpoint by subtracting half of the size. So that's assuming the rectangle is centered on the center of the object. I don't know if that explained it, but like we might have, like later we might have some bosses which are big, right? Or some elite units of some other sort. And those will have bigger rectangles, but the math is still the same. Like, see if we could, just as an example, let's scale this down to a weird shape. The math doesn't change here. Like, this is still not colliding. You move it up, and now like the max X is inside, and the min Y is inside the dimensions of this one. Does that help you visualize it, Isaac? Let me know. In the meantime, let's do the recording. So now that we've collected all of these, and this needs to be mute in this case, we're taking a mutable iterator here because we need to change that collider. Excuse me. Okay. I think you might miss A colliding with B, but you will find B colliding with A. How so? Okay, so yeah, let's think about that thought process. Okay, so let's say A is the orange square, B is the green square, or the green rectangle, orange rectangle. So if we are going through the first time, so A is it's orange is A in this first pass. We will find. Let's get this over here. Bump down this text size a little bit so we can see it side by side. Okay, so we will find that if this is B, the min B of X and the max B of X are those. Does it contain the min AX? No, it does not. Does it contain the max AX? Yes, it does. Oh, I see what you mean. You're thinking like this. That is actually a collision. Okay. Well, let's just this is a simple computation. I think this is a good counterexample. Thank you for calling that out. So if this one is shaped like this, we would find that B collides with A, but A does not collide with B because the min and max are not within there. So let's add the additional conditions here. So we're going to duplicate these, right? And we're going to say this is, let's make a bijective condition here. Okay, so now we're checking, are any of the min and maxes within? And that would be, in this case, yes, because we have checked that this one, yeah, because we would also miss the case where something is completely contained. Like it would go, well, yeah, the green one is, but the orange one isn't, right? So that's a good point, Isaac. Thank you for calling that out. And let's copy that and we'll change all these to Y's. There's probably something where like a geometry library we could pull in and go, let's create some rectangles and see if they overlap. And it probably has implemented all of this for us. Okay. Thank you, Isaac. That was a good find. Again, this would have been way simpler if I said, yeah, let's use circles. Or ellipses even. Ellipses would be fine. You just have to check the angle as well. Or you'd have to project. Yeah, you'd have to scale the angle between the two centers. That would be interesting. Okay, but we're doing rectangles. Okay, so now that we've got all the collisions collected, we're going to loop again through the entities and record the collisions on them. So let's say, so collider.collisions. We're going to say collisions.get entity unwrap or default. So if we never inserted anything, then so that's an option. Let's say cloned. Actually, we're not gonna clone. We're gonna remove it because we're just gonna throw this hash map away at the end. We might as well pull out the thing and take ownership of it. Okay, so we're just, every time that we're detecting collisions, we are replacing that entire collection of entities that's colliding with. Okay, so let's make a little debug No, let's not do that yet. I was going to say let's make a little debug system that would print out these collisions. But for now, let's just run this and make sure that we're not we're not crashing anything. Okay, so it's still working. Let's see. So we should have had a collision there. And let's instead of doing that, let's do not concat is empty. Found a collision, found some collisions, and then we'll see. The entity here is not that useful, but we'll print it anyway. Okay, because I want to see that like our math is working here. All right, guys, kamikaze. Okay, and I think the answer is our math is not working. So we should be seeing a bunch of stuff printing out here. Okay. And let's go and look what the tutorial did. There's probably something in here that I'm missing. Okay, so, they did radius based. This tutorial was more of a spaceship, like asteroids shooter thing. Right, so what they were doing was take the translation, compute the distance between them. And if the distance is less than the radius of each of them, the sum of the radiuses, the radii, then it would add it. Okay, so that's interesting. I don't know why he's clearing and not just taking it from the hash map. There's probably something to do with memory coherence or something, but like reusing the space that was previously in this vec. But essentially they're doing the same thing. Now, they're doing handle collisions separately, but we essentially did the same thing. So there's probably something wrong with our math in here. Real quick, let's look at the Bevy docs, or the Bevy cheat book maybe, and we'll see if there's anything in here. No. Okay. Let's see if there's any geometry utilities in here that we might be able to make use of. Nope. Pet graph is fun. That's not useful though. Okay. I look at the math. Now this math is actually probably a the most part a re-export of glam. Now we can make a rectangle and see if we can intersect. Okay, this might simplify our math here. Let's do this. So we have the, let's make a, let's see how we construct that. And here, let me bump the text size back up. From center and half size, or from center size. Okay, let's do that. Let's call it bounding, call it rect A. We're going to say rect from center size, and the center is transform A, translation, truncate. Yep. Those are vec2s inside there. And then the size is collider A dot size. So it pays to read the documentation here. Okay, so that's going to simplify that, and let's do the same with B. And it's a bit too far to the left for me. Okay. Rect B is rect from center size. Center size. There we go. And that's transform B, translation, truncate. And this is collider B dot size. Okay, and then we're going to dump all of this because this is going to become really simple. Okay. So what they're recommending here is see what the intersection of those two things are. A new rectangle formed at the intersection of this rectangle and another rectangle. The intersection is the largest rectangle enclosed in both rectangles. If the intersection is empty, this method returns an empty rectangle. So is empty returns true. But the actual values of rect, min, and max are implementation dependent. That's fine. All we care about is empty, which means that there's at least one zero dimension. Okay, so if we say rect A intersect rect B, if it's not empty, then we will add that. Whew. Okay, that's a lot simpler. Yay, Bevy, thank you. Let's see now if we get some collisions, right? Yep. And here come the ghosts. Okay, so there's still something wrong. Oh, I know why. I'm glad we found that and we simplified our math there. But the reason why is we didn't add colliders to any of our entities. So, and the other thing we didn't do is we didn't add this plugin. So let's start by adding the plugin. I don't want to use it though. I just want to refer to it. Okay, so we add the plugin, and now we actually need to put this entity, put this component on our player and on our ghost. Okay, so okay, so we probably need to make a constructor for this. Let's go ahead and do that. New, and let's say size is a vec2. Self size collisions is going to be an empty vec. Okay, and this will return self. And then that'll be a little bit nicer over here. So we don't actually care about constructing the collisions. So let's make a collider. And really we just need the dimensions of our sprite for now. So let's find that. I think they're honestly all the same size. So 97 is our little knight, and he is 16 by 16. So okay. Let's see, that's private. Let's make it public. Okay. So now the player has a collider. And let's look really quickly at our ghost. I'm pretty sure it's also 16 by 16. Yep. Okay, so that makes it pretty easy. Is splat const? It is. So let's put that into a constant. Then we can adjust it later if we want to. Const player size. So vec2. Okay. And then we'll say player size. Okay, let's go add the collider to our ghosts. So is also vec2, and we're going to splat 16 again. Sorry, the splat is a constructor that just makes a vector that has both elements of the same value. Okay, and we'll make a collider. New ghost size. Okay, so now we have both the ghosts and the players. And we should get stuff printing out if we didn't remove that. Okay, so let's run this and see what we got. Okay, ghosts are spawning off screen. Let's run into them. Wow, we got a lot of prints. And yep. And so one thing that this should be fine. I was gonna say one thing that we maybe should do is clear the old collisions. But we're just reassigning it, and I don't know that there's a particular problem yet. We would need to do some profiling later to see if this is actually going to be a performance problem. But yeah. Okay, so we were able to verify that our rectangle-based intersection collision detection is showing the correct stuff. Now, the other reason we might want to go ahead and clear, and let's do that, is that if there are lingering detections from the last frame, we'd want to make sure that they're not there this frame if they're no longer valid. However, I don't think that that's really necessary on this. We are replacing it every time we compute it, so I don't see any reason why we would need to clear, because we're completely replacing the thing. Okay. Um, let's look at our to-do list. Okay, so we did some basic collision detection. We're working on that. One thing that, from a gameplay perspective, would be helpful, and I don't know that we can do that today, but we should think about it. I've been kind of idly thinking about it when I was thinking about what to do on today's stream. So we've detected collisions, but nothing happens when something collides. In the tutorial example that I've learned a lot from, what they do is despawn. So in the case of their asteroid style game, if the player has fired a missile, and that missile is colliding with an asteroid, then both the missile and the asteroid should despawn. They should be removed from the game. I think that we will want to handle collisions for specific kinds of collisions in our case, because if an enemy just touches a character, we probably want to take away hit points from the character, right? So if a character swings a weapon or fires a weapon and that weapon hits an enemy, we want to take hit points away from the enemy. Right? But also, Jesus, my cat. I'm sorry. She is very, very, very silly today. Rubbing her face on the back of my monitor, so you probably see my camera shaking. So if two, like if an enemy and the player collide, we probably want to have some like knockback, like, and then also maybe because collisions are being detected like really rapidly, way faster than the user can react to them. Shoot. Give me a second. My cat is being a real pain, and she just disconnected the monitor. You need to leave that alone. Well, that was not fun. All right, I'm gonna switch to break time and I'll be right back. All right. I just said thank you for being tolerant of my technical difficulties. My cat got really, really interested in my monitor and bumped it, and that made it awful. Okay, so we want to think about, and here she is again. We want to think about knockback, maybe a temporary invulnerability from knockback from collisions. And maybe let's move this down so we can do player hit points first. Yeah, because I don't think what you would want to have happen is you get touched by an enemy, and then that enemy touches you so many times before you can react that all your hit points are gone. Like, that would be awful, right? So we need. She's being very difficult. Say hi to the stream, Bianca. Very naughty kitty. Yep. We need a way to make sure that after a collision happens, we're not causing the player to instantly die. If we have more than one hit point, or maybe we have, because like Crafty Survivors has, you can earn, as you progress through the game, you earn more hearts. Whereas like Vampire Survivors, each character has like a hit points bar rather than discrete points. It's continuous, and it depends on the enemy's damage. So all sorts of things we should be thinking about. But for now, maybe we will do. Let's add some player hit points, and then we'll go and see if we can do knockback from collisions. So if we collide with something, we should add a force to the player's movement that pushes them away, and also maybe the enemy. It might be nice to do it both directions. Okay. So I'm out of water. All right, let's add player hit points. So let's go over here. We'll probably want these eventually on the enemies as well. So maybe let's make a new module. Ha ha ha. And let's call it health. No, don't do that. Don't do that. It's going to be a long stream if she keeps doing this. Okay. No, let's delete that. I didn't want a folder. I wanted a file. New file. Health. Okay. And, this is maybe a little bit premature optimization, but, or, being a bit overly modular, but we're going to do it again anyway. Like, we'll be able to find our health system in one place. And then what we can do is also, I think we will want soon sub schedules. So we will do something similar to what the spaceship game tutorial does, where you create a set of phases within our update phase, which makes sure that things happen in specific orders. So nope. Stop that. All right. Come on, cat. I'm sorry, I don't have an extra webcam. I can't put it on the cat. Otherwise, you'd be getting all of this entertainment, except you can tell she just walked across my keyboard. Okay. Let's put a to-do in there because we don't know what we want. Okay, so we're going to probably want to say, let's make a health component. Component debug. And let's just make an F32 for now, I think. Now we could do something like U32 and have discrete health points. That might be a simpler system. Yeah, yeah, let's do that. So maybe we'll set this in the player. Um, okay. So what are we going to do? Um, let's make a system that we're only going to be concerned with damaging the player right now. So let's say player, let's say decrement health, or what do we call it? Let's say take damage. Let's call it that. Okay. And then we're going to have a query which is going to be, it's going to have a mute health, and we're going to maybe have some commands in here. We'll see. And it's going, we're going to need the collider, right? So we need that collider component. And then we only care about the player. Okay, so let's say okay, and this needs to be mute query. Okay, and let's just do something really simple here. Let's say if collider dot collisions, if it's not empty, right? We don't actually care at this point what it collided with. The other option is that we could say, let's get a query that just gives us the entity, and it's only enemies. But for now, let's say we'll just take off 1 health per tick per frame, basically, that it's colliding with something. So let's say health dot amount minus equals 1. And let's put a little info in here. Player got hit. Health is now health dot amount. Let's see, put health dot amount. Now we're gonna have to be careful here because this is a U32. We want to do a saturating sub. So saturating sub. This will make sure that once it's 0, it stays 0 and doesn't wrap around. Okay. Okay, so we're going to do like we did before. Add systems, update. Maybe we'll do post update. I don't know. Post update. My cat is being ridiculous. Okay, let's go and make sure to add the health plugin. Okay. So, okay, to review what this system is doing. So remember, systems are run automatically by Bevy. with the ECS scheduler. So we are running this in the post-update phase. So this is after it's updated everything. It is probably not the right thing to do. Probably what we want to do is deal with the deal with these in sub schedules, like make system sets. Okay, so we're trying to get the player. I think there's a way. See, single mute panics. Right, so maybe we don't want to panic on this. Let's convert this into a loop. Although maybe let's look for query. I think it's get single mute returns a result. Yeah. Let's do if let okay or maybe we do let okay get single mute else return. Okay. I just want to make sure this doesn't panic. If we later decide that when the health of the player goes to 0, that we despawn the player or something of that sort, then this thing running we would not want that to panic our game. So single mute is not will panic. Get single mute returns a result. So that's probably, I got a nice example here. Similar to what we're doing. Okay. So, nope. Stop moving my monitor, dear. She is really active this afternoon. Okay. So let's go and put some health on our player. Player starting health. Do it like we were doing before. Let's say they have, I don't know, 30 health to start with. That's a lot. Okay, and then we're going to say health amount is player starting health. We could probably make that a tuple struct or maybe make a constructor. I think this is fine for now. If we ever do anything like this, like maybe we have, I would probably make that as a separate component, but maybe if we had like armor or something like that that could decrease damage, that might be part of the health. Or maybe there's a shield. I'm not certain. Okay, so we should print out when the player got hit. And probably what we're going to see, given how much these collisions are happening, we're going to see the player lose a lot of health really fast. And so we may have to implement that knockback system. Okay. So nothing has hit me yet. Nothing has hit me yet. Yep. See, look how many times, how quickly the player's health went down to 0. The other thing is that we could potentially, in this system, this take damage system, let me kill that. In this take damage system, we could have a timeout. So remember I was talking about maybe there's an invulnerability period. we'll do the knockback. Maybe what we'll do first is, since we have hit points now, let's say, let's do temporary invulnerability. And what we'll do this with is a timer. So we're going to do... let's say let's give it a timeout, and this is going to be a timer. So we're going to need in here the time resource, so that if and then we're going to do timeout tick time.delta. Okay, so this makes sure that and we'll need to initialize that with something. So let's go ahead and make a constructor. And this is, sorry, I need to make this return self. Okay, so we'll take the amount, and then we're going to say timeout is timer let's make it a quarter second, and this is timer mode once. Now there's something to be said that like there might actually be two states. One where okay, so we always tick. And I think that we need to go look at the docs for this, because it's probably really, really interesting. Remember, we had that thing previously where we were not ticking an internal timer, and that had to do with that was our spawn timer, right? So timer. Okay, so we're going to do from seconds, and then okay, so there's a question in my mind. So if we tick, okay, so non-repeating timer will clamp at the duration. So what we can do is say, and let's look at this. We will reset, right? Yep. Okay. So we always want to tick, and then if the collisions are not empty, and the timer. Oh, hi, Brian. Yeah, you want a state machine. I think like a collision occurs and the health is decreased, you can't decrease it again if the collision is not collision, right? So we're giving the player a quarter second duration, but the there's a question. So we need to think about the initial state, but what I want to think about is the post collision state first. Um, so if there are collisions and the timeout is finished, that means we can reset the timer. So if it finished, this means that that we have reached the timeout at after a collision, and the player can be collided with again, right? So we're going to reset this and give it another quarter second. Now, one of the things that we will want to do, and let's do this as an else. We want to think about what is the state the initial state. Because what I want to do is start it in the finished state, right? So like when you initialize this thing, you've never collided. Now, what we could do here is make this an option of timer. And then start with none, right? And then that would mean at the very beginning it's never collided with anything, it's never taken any damage, and so you have you've not started the timer. That makes this a little bit more complicated, but let's make this a little complicated first, and then we'll simplify. Okay, so we still want to check. Okay, so if let's sum okay, what are the conditions that we can take damage on? Either they've never taken damage before, so it's none, or it's sum plus the timer is finished. Right? Also, Brian, thanks for coming to the stream. I don't know if I mentioned that. Glad you can make it, and I hope you're enjoying the holidays. Okay, so we could say let's first handle the case where it's none down here. Let's timeout health.timeout.asMute. Okay, and then we'll do timeout tick. If you're not familiar with asMute, this turns a mutable reference to an option containing a mutable reference. Very, very useful. Its pair for immutable is asref. Okay, so yeah, this is all broken. What do we got here? Yeah. No, else if can be collapsed. Here, do it for me. That. There we go. Can it really? Okay, cool. Okay, so if the collisions are not empty, then probably what we need to do is have something like, let's start by matching on health.timeout, and we'll say if it's none, then if there is no timeout in here. Yeah, I know. Okay, so what is the other case as well? If there is a summer a timeout, and we have timeout finished, then we want to reset. If it's none, then what we want to do is health.timeout.replace, or is it insert? Insert. Interesting. We could do get or insert. Now let's go with this, and then we can maybe think about how to simplify this later. Okay, so here's where we're going to do timeout from seconds, or timer, excuse me, 0.25, and then it's going to be timer mode once. Okay, and then for anything else, we just want to return. So like the timer is not done. It wasn't in the none state, so it had occurred before. And I think we actually need to not do this in the else. I don't know why I was doing that before. Okay, so this is not the best. Timeout. Oh, we want timeout.reset, not health.timeout. And we want, yep, okay. Let's say mute, like so. Okay, so let's walk through this so that I can be clear with myself and you all can correct me if I'm wrong. Okay, so we are trying to get the health and the collider for a player. And if we are able to get that, so the player does exist and this entity, this query is satisfied, we will get the health to be modified and the collider to determine whether it's collided with anything. Okay, and if this taking damage has a timeout, it has a cooldown, right? That might actually be a nice thing to rename it to so we don't get confused with timer. Let's rename that symbol to cooldown. Okay, so if it has a cooldown, and let's rename that to cooldown as well. Anywhere we're using that, let's rename it to cooldown. All my cats have opinions today. Okay, so if we do have a cooldown active, then we tick it. So we make sure that it keeps track with the game time, right? The wall clock time. And then we check if there are any collisions, right? If there are collisions, then let's look at the cooldown, and if it has finished, then we'll reset it. So we're starting it over which means that that cooldown had completed. Um, and what we want to do on the next tick is make sure that we start that cooldown over. Okay, if it had never started, then we'll replace it with a new timer. And this kind of hard-coded bit is not great. Maybe what we could do here is like add the cooldown delay as part of the constructor of this, and then create the constructor from the health thingy. And the reason why I say that is we may want to give the opportunity for the timing on this to be different. So like enemies could be damaged faster by weapons than users might, or than players might be than with collisions, right? Okay, so but we won't worry about that right now. We can fix that later. Okay, and then if it's anything else, so like if it's an active timer, then we don't want to do anything. We don't want to decrease their health because the cooldown has not completed. And so we'll just return from the system. Okay. I think this makes sense. It's not my favorite code. We should be able to hopefully improve this later. And let's give this a whirl and see how quick. Oh, right. Okay. So we need to go over into the player and make sure that they're using that new constructor we made, as opposed to trying to build the struct directly. And then we can maybe make these not pub. There we go. I figured out how to do column selection the other day. It's very useful for the thing I was editing. Okay. What problems we have? Cannot move out of dereference. Okay, so we need to do that as mute trick. And then this will be a mutable reference inside there. Variable does not need to be mutable because it's already reference. Okay. That should fix that problem. And my cat needs to stop, please. Come on. This is what I get for mounting my monitors on on arms. Oh, I actually need to take damage. Now note that it's not like, it's every quarter second. It's not, instantaneously. And when we stop colliding, it stops printing out. So I think we did a pretty good job there. Yeah. So our player takes damage when they get touched. But they don't take it any more than every quarter second. Source. Look at that real quick. I should have made a commit earlier when we finished the collision itself. Okay, so let's add player, add collision detection, and player health. Okay, so let's look at our to-do list. I think I'm pretty close to wanting to wrap up, but maybe what we could do is add the knockback. So I'm not sure where to put this yet. Maybe we can do it in collisions for now, and then if we need to move it later, we'll move it later. Okay. This would be so much easier if my cat would just sit in my lap, but she doesn't want to. Okay, so we need. What are the essentials of this? We need to know. We need to know the. We're gonna knock back the player, right? I don't really feel great about this, but let's forge ahead. Let's see what we can do. Okay, so we need a collider. We need the transform. We need. And this is going to be for the player. So we want to get, and we actually need the velocity as well, because what we're going to do is modify the velocity. Mute. Okay. So, and what we want to do is have the, let's say this is just player, right? The player query, and then we'll have the enemies query. And this is going to be really what we're just trying to do is get the transform. Maybe we just do the transforms, because we're not going to iterate through this transforms query. We're only going to look at the things that the player has collided with, and what their transforms are. So we want to, let me get back my little diagram thing here. Okay. So let's say the player collided, so the player is orange, the enemy is green. What we want to do is exert a force on the player that is in the opposite direction of the enemy, so it's knocked back, right? And this should be, I say it's a force, it's an acceleration. And this should be in the same direction as basically center to center. So we don't need the rectangles of them. We really just need, and we could scale it by, some normalized version of the dimensions of the collision box. But for now, let's just think about center to center. And so we would expect that, if we draw a vector from the center of the player to, or from the center of the enemy to the center of the player, then we'll add an acceleration away from the enemy. Now there's a question of how much, and I think what we want to do is add up. So like have a constant amount of acceleration, but add it up based on how many things it's colliding with, so that the direction gets adjusted based on what it's colliding with. And we'll see. There's a question in my mind about whether I guess we'll try it out and see what happens. I think we want this to be acceleration, right? Not velocity. This needs to be acceleration. So we need to... the other thing is, which I'm kind of wondering if we should have put the cooldown on the collision and not on the health. Well, let's put the health in here, and we can check whether it's in cooldown. That should be fairly straightforward. Except then we'll need this. Let's just make them pub again, so that we can use them. This is a sort of a cross-cutting thing that I'm not sure about yet. The design. We may need to revisit this design later, but I think we can probably get this knockback at least partially working before we call it today. And on a logistical note, I'd like to try to do tomorrow as well. Pay attention to social media. I'll make an announcement on there when I'm going to start up. I'm not sure yet. It might be earlier in the day. Hopefully that'll be nice for those of you who are watching during the day or are in Europe or something like that. Yeah, let's do one tomorrow. Okay, and we need to import that and import that. And why are you not working? Okay. So now it just thinks it's not being used, which they aren't. Okay, so let's do that thing again where we do, so this is going to be collider, health, player, let's just say transform, mute velocity. I think we want to do time. And that's because what we need for acceleration is the amount of time. Okay. Now we could apply the acceleration for the duration of the timer. Let's think, maybe we'll do that. Let's not use time yet. Okay. So we're going to say player get single mute, right? Else, not if, let, let, else return. So if the player is not in our world, then we don't do anything for this. Okay. So we have some similar things to the health collision, the take damage system. We don't need to tick the cooldown on the health, but what we do need to check now let's have the time. I don't think that using that internal timer is correct. We're gonna have to make use of that. Okay, so what we need to do is let's make a knockback, which starts as vec2 0. Right? And then what we're going to do, let's do vec3 0 because we're in 3 dimensions, even though we're looking like we're in 2 dimensions. Okay, so what I want to do is we're going to we're having some timing things here that I'm concerned about, because in our take damage system, this resets the timer, right? Um, and if it doesn't reset the timer, then it's ticking. But if this take damage system runs before this knockback player system, then we don't know, like, that's not an adequate way to determine whether we should be accelerating the player. Now, maybe what we do, I don't think this is correct, but maybe what we do is we start with, even if it's in cooldown, we are pushing the player away from those collisions. It's probably going to be a little bit crazy. The other thing we can do potentially also is, I was thinking, this is like physics class. Maybe we need Rapier 2D actually. But we could include the velocity here, and then it's not just the direction that they hit, but it's like there's some combination of the direction to the object plus its velocity that determines, and then the player's velocity, right? Determines the direction it gets accelerated in. We could start with elastic collisions, or maybe we could do inelastic collisions. There's some physics there that I would need to read before we do that. So maybe let's just start with the transform, like we talked about, and then we'll make it more sophisticated next time. And let me put that in here because I don't think that we're going to get to it. I just want to let's say inelastic collisions with let's just put that. That'll be enough for me to remember. Okay, so these are going to be completely arbitrary. They're not based on the velocity of either object, right? And this velocity here is just so we can modify the velocity. Okay, so let's oh, and since we already have this as 0, if it's not colliding with anything, we don't have to do anything. Okay, so let's say collision in collider.collisions. So that's an entity ID. And then if we say if let okay, I'll say enemy transform. Transforms dot get collision. Okay, so if there is a transform for this entity that we're colliding with, which there should be, otherwise how did we know how we collided? Which, in that case, let's just do let's see, that's query, what's get. Okay, let's look at the Bevy docs. Okay. Get single. Where's the get? Honestly, let's just unwrap it. So let's say let enemy transform, because we know that in order to have collided, it has to have a transform. So this is let's do expect collided with entity that has no transform. That is an error condition in our program that we don't want to happen. Okay, so now let's draw a vector between the player and the thing it collided with. So let's get a direction, and that's going to be the transform.translation minus the enemy transform translation. Okay, and then we have this thing. Let's do normalizer 0, because if they're right on top of each other, it actually doesn't matter what direction. Is it? Let's see, try normalize. Let's pick an arbitrary direction. If they, I don't think that this is I'm just picking negative x for no good reason. I don't think that there's a case where we would, because we're going to apply this knockback. Okay. Because we apply this knockback, I don't think that there's going to be a case where they can actually be right on top of each other. That would be the case where we can't normalize it because there's no distance. But if there's like some computation error, like some floating point error, we probably need a default there. So it's smart to just try to normalize that. And then, so the acceleration, let's just say it's 5 units. Direction times 5 units. And then let's say, so velocity, okay, so that's like 5 units per second of acceleration. So our knockback amount is the amount the velocity is going to change. And so, you know, multiply by the amount of time for the acceleration gives you velocity, the dt. We're doing differential equations. We're doing integration right here, right in code. If you never thought you needed that calculus, now you have a little bit of it. And let's ignore the health for now. I think that was confusing things. We're not going to use it. I really just want to change the velocity. So we're going to say velocity dot value. It's private. Okay. What did we do in here? Oh, change direction speed. So we need maybe what we should do rather than this is just add up the accelerations. And let's make a method on here called accelerate knockback, because we'll probably use this later. Time.elapsed seconds. Okay. And then in velocity, we will say accelerate. And this is going to be a vec3. This is a direction or acceleration. Hello. Vec3. And then the dt is going to be an f32. And we need mute self. Right? Okay, so we say self.value times equals acceleration times dt. Differential equations. Okay, so so if, just to check the idea here, if our player's not colliding with anything, this knockback is going to be 0. And which says that our acceleration is wrong there. It's going to be plus equals. Right? So if it's 0, we shouldn't change the velocity at all. And the velocity is being changed by the player's movement, the key. So we are going to have you know, some issues with timing, like when are these things applied? You know, is there, maybe we need to think about, is there a duration at which the player's being knocked back, like over a particular amount of time? That's something we can adjust later. Maybe what we do here, instead of actually changing the velocity, we add a knockback component, which every tick accelerates while this timer is good. That's actually a really good way to think about this, that it accelerates the user, the player, in that direction. Okay, but for now we'll do this. It's going to be janky. We're not going to be happy with it. It's not going to look right. Let's fix these warnings and then we can run the thing. So we're not using the health. Okay. That is not being used, so we needed to put it in. And then it thinks that's not being used. Yeah. So we're going to add update knockback player. Okay. So let's run this and see what we got. And I'm just going to let it sit here and let the ghosts run into him and see that he gets knocked back. Right? They're converging. And he's not moving. Okay. And the player's dead. Okay. Oops. I didn't mean to quit that. I just meant to quit the app. Yeah, I'm not running it. Okay. So that was not correct. And probably what happened was the tick was so small. Let's do if knockback. I should do part like approximate equal, but let's say if knockback dot length squared greater than f32 epsilon. I don't have the approx crate in here, which I would prefer to use, but this is close enough. If it's not greater than the error, or if it is greater than the error amount, then we want to say knocking back player with acceleration, and then we'll knock back, right? Because I want to make sure that like this is actually getting run. Okay. Yep. Let's run that, and then we'll wrap up for today. And I think we can do some smarter stuff tomorrow about this. I think that idea of having a knockback state on the player is probably the way to go. Okay, so they are getting knocked back. I don't know that those make sense. Right? But we should see, maybe it's this, like similar to our first session, maybe this is too small. Maybe we need to be like 30 or something. Because 5 is like, you know, acceleration doesn't have the same units as velocity, but 5 is like 1/3 of the player's width. So maybe we need something bigger. Let's see that and see if okay. So it is not, yeah, I think what's happening is that we're, oh, that was interesting. Did you see him pop? I didn't press any buttons. Let's see if anything happens on a different, yeah. Oh, look, he got shot way off the screen because they're following him down here. Okay. That was fun. Okay, so I think what's happening is the order matters here. And what we probably need to do is have something like have a knockback component, which has a timer in it. So for how long is the player knocked back for? And the direction they're being knocked back in, right? And maybe we have something where the magnitude of the acceleration, and we're probably going to have to just add acceleration to our movement in general, but we apply the acceleration over a diminishing amount over that time. And then if the timer has elapsed, then we remove that component, so that on the next tick, if they're colliding with something new, they can get knocked back again. I think that's probably what we'll do next time. So let's say knockback component, which has the amount and the timer. And maybe what happens is this system, rather than adjusting the player's movement or position or even velocity, what it does is if there's a player, if the player is not being knocked back, so we would need to add that condition to our our query filter. And I would have to look into how to do that. So we would have to research that. But if the player is not being knocked back, then we can add a new knockback component, which is the acceleration away from the collisions, and a timer for how long they're going to be knocked in that direction. And then on every tick, we can also apply the acceleration of that knockback to, or maybe it's just velocity. Maybe we make it simpler and it's just velocity. Add a portion of that to their position. And then when the timer ends, then they're no longer being knocked back, and we remove that component. Okay, so that was kind of a complicated way of saying this is where it's going to get more complicated. This is where it's going to be more difficult, and we're going to have to think about the ordering of events. We might need to do something like add system sets so that we can group our systems into particular orders within the update phase. And I think that was wrong earlier. We did, on one of these, we did post update, or we picked update and we didn't tell it, like, yeah, we did post update, take damage, right? We'll probably want to say, do something like at the beginning of a frame, take care of any few things that happened at the end of the last frame. And for instance, if there's something that reaches 0 HP, remove it. And then any of those entity changes we flush from. So if there's any despawn things, we flush those entity changes, and then we start processing the entities that are currently active. And yeah, and that's I think that's a good place to leave it. Let's look at what we added. Let's say incomplete knockback after collision. We don't have to have knockback in this game. I kind of like the idea because it gives you an opportunity to both like a visceral feeling of taking damage, if we can get it to work, but also it gives you the opportunity to try to evade enemies. It gives you the opportunity, like, I got a little bit farther away from them. So I think it's a good mechanic to have. All right, so let's do that, and I'll push everything that I have, and let's wrap up today. So we will want to also start to think about player attacks if we can next time, and then maybe think further down we could do obstacles. So making sure that you can have things that you can dodge around or get enemies caught behind. And we'll probably want to do things like make sure enemies don't overlap or not too much. So they will have to deal with those like enemy to enemy collisions. And either adjust their translation or maybe give them a little bit of knockback from one another. That could be kind of funny looking if they knock back each other without taking damage. But yeah, there's lots to do. I hope you all are enjoying this, kind of are muddling our way through developing this little game, and we'll come back tomorrow. Again, watch social media. I will let you know when I'm coming back, and probably give you a couple hours notice. Thank you, everybody. Thanks, first time chatters, for saying hi. I hope to see you again soon.